Hi guys, I'm Mr. Canizero. I'm one half of the chemistry team here at SB, and I'm going to be some of you guys' chemistry teacher this year. I'm looking forward to seeing and getting to know you guys. We're going to be starting in about 2 weeks, and Mr. Risner and I have a great semester planned for you, so I hope you're looking forward to it. Talk to you soon.
Hey guys, it's Mr. Risner. Just saying hello, and today we're going to show you some of the things that you're going to be using in the lab this year. Alright, so first we're going to talk about the things that are in your lab drawers. These are all for you to make sure that there's no cross-contamination. You have a number of beakers. They're different sizes, so this one is 250 milliliters. This one is 150. This one is 100. And this is a 50 milliliter beaker. The markings on these don't go all the way to what they say. Like this one only goes to 40 milliliters for measuring, but it holds 50 milliliters. You've got a variety of test tubes, one larger one and 6 smaller ones. You have one flask that's 250 milliliters. It says on it that to stopper it for storage, you would use a rubber stopper that's size number 6. You have a well plate. This is for doing multiple small reactions where you're changing different factors about them. This is an evaporating dish where if you've done a reaction and you need to evaporate the liquid off to get a solid product, this is what you would use. You'd use the flame under it.
You've got 3 different size graduated cylinders for your personal use, and they are here as follows. We've got a 100, a 50, and a 25 or a 10. We also have other sizes available in case we need them, but these are the most commonly used ones. We have a crucible and a cover, and this is for heating reactions up or substances up to very high temperatures. These are ceramic. They're very expensive. The cover is actually more expensive than the crucible itself, all handmade. This is the clay triangle that the crucible sits in, and then this would sit on top of a iron ring that would be attached to a ring stand, and you'd have a Bunsen burner under it. Clay triangle is also helpful for holding a funnel. I'll give you one small funnel. We have other sizes as well. This is a single burette clamp, and it can hold a variety of different things. It's sort of a general purpose item, and it attaches to a ring stand. A watch glass cover. It's a concave or convex. We usually put them down concave so that any liquid that would evaporate out would drip back down in and not run out if it were like this. You can also use this on top of a beaker if you need to temporarily cover it for any reason. A wire gauze. The wire gauze is used to put on top of a iron ring attached to a ring stand. A plastic stir rod. Forceps for grabbing small items. A test tube holder, so that attaches like that. Careful when you squeeze it, the test tube falls out. There's a scoop or scopula or spatula. They're all names used interchangeably. This is for obtaining amounts of substances, maybe over at the balance or in other uses or applications. We have crucible tongs. These are specific to grabbing a crucible, picking it up. You can also use it to take the cover off when it's hot. We have beaker tongs. These are made for grabbing hot glassware, picking them up off of a ring stand on a, after they've been heated or off the hot plate. These don't get used on anything that is super hot because this is plastic and it'll melt. A spark lighter that's used to light a Bunsen burner. It has a flint here. These are removable when they wear out and can be changed, and they make a spark. And then finally, everybody's going to get a wooden test tube rack. This is a larger 12 tube size. We also have smaller 6 tube sizes, and they hold a variety of different size test tubes. And that's it.
All right, so this is some of the Labware that we don't have enough of for each person to have their individual piece, but we do use them on a regular basis. We have ring stands, will be this and the base here. They support various clamps. So here, this is the iron ring that's clamped to it. And again, you can use the iron ring with your clay triangle. You can put on an evaporating dish and a Bunsen burner, and that's how you would heat this up to evaporate things. You can lower it to be right in the flame. Another thing that you can attach to the ring stands, this is a burette clamp. It's called a burette clamp because it clamps onto this, which is called a burette. A burette, when you look at them up close, you'll see that it says 0 up here. And that means that it's not measuring how much is in here. The numbers are measuring how much liquid has been dispensed. You use these with the valve, similar to the valve on the gas. Inline means open, and horizontal or perpendicular means shut. Okay, these do not screw shut. If you try to screw them shut, it'll just keep opening and closing. We're going to be using hot plates for a number of reactions. This is a pneumatic trough. We'll be using these near the beginning of the year as well. I'll show you what that looks like set up in a moment. It's used to collect gas that's produced in a reaction. These are calipers. They're used to measure things that are usually difficult with a ruler or meter stick. Like, for instance, I can measure the width of this circular object. Occasionally, you'll be using these distilled water bottles. These are squeeze bottles to rinse things off. They have distilled water in them. And you don't tilt them because the hose goes to the bottom. You just squeeze them to use them. If you're doing a reaction that's going to take a long time and require a lot of mixing, you would use a magnetic stir bar and a magnetic stir plate. So you would take out your beaker, you would put in the stir bar, you would plug this in, and then you'd use this dial and it will stir your reaction for you. And last, we have pipettes and a pipette bulb. This pipette, it's graduated, it has numbers on it for measuring, and similar to the burette, the number 0 is up here, because again, this is for measuring how much you have dispensed. This is a volumetric pipette. It has only one line, but that one line is for 10 milliliters of liquid. This is a pipette bulb. You gently insert the pipette tip into it. Provide the suction to move one liquid from one place to another using the pipette tip.
Chemical reactions that produce a gas are very common, and oftentimes we want to capture the gas that's produced in that reaction, or a reaction. One of the ways that we can do this is through the use of a pneumatic trough. And a pneumatic trough is nothing more than a device designed to allow the reaction to occur in one vessel, in this case a test tube, and make its way or migrate into the pneumatic trough and come out through a port in the bottom of the trough. You can see this tubing here goes from the test tube all the way over to the bottom of the trough. This trough also has an overflow outlet, which this tube is just a drain into the sink. So the reaction would occur in this large test tube, and the gas that's generated would be forced out through the tube, and it would bubble up through the port that's in the bottom here. In order to capture it, we need to put some sort of a container over the top of the hole. That container could be something as simple as a graduated, or a bottle, let's say, with no graduations, or we can actually quantify the amount of gas that we catch with the use of a graduated cylinder. So we do this by what's called water displacement. So what I'll do is I'll put the graduated cylinder in the truck, and I'll very carefully let the water run in, and the air will get pushed out. So right now you can see that I have completely filled the graduated cylinder with water. This is ready to capture gas by simply taking the end of this and putting it over the hole in the bottom of the trough. Sometimes you need to support these with your hand or maybe a ring stand or something to hold it in place. This one is just sitting there because the diameter on the cylinder is large enough to act as its own stand. So now at that point we could begin the reaction, and any gas produced would push the water out, and you'd see it bubble up to the top and slowly force the water out the bottom.
All right, here we have a fume hood. This is for where you would do reactions when they might produce fumes that you don't want in the room, or smoke. They have lights and an exhaust fan. Here we have an eye wash station and a shower. Eye wash station is operated by the foot pedal or the hand pedal. The shower operated by the handle. This is the broken glass container. Please don't put broken glass into the garbage. It can rip the garbage or injure whoever's taking it out. These are all of the cleanup kits, whether it's an acid, base, solvent. These are what you would use depending on what it was. Here we have the fire blanket to wrap somebody in if they are on fire. This is the drying oven. If you need something to dry overnight before weighing it, this is where you would put it. This is a first aid kit meant for small things, small cuts. Each room has a fire extinguisher. Each room has a sign to tell you where to go when there's a fire drill. And each room has a gas shutoff valve. Similar to other things that we've discussed today. Perpendicular means shut, and inline means open. So if there's an emergency and one of the other faucets can't be shut off, then you would shut it off this way for the entire room.